So far in our look at software sustainability in practice, we've looked at a situation in which we've imagined that we have invented the Pythagorean theorem. We've written a piece of software. We've iterated it in terms of quality, because at first we ignored anything to do with sustainability. We just wrote to the compiler. So we iterated it according to coding practice and made it incrementally better. We then talked about version control because we felt like we'd reached a stage at which we were happy with the version of the code that we wanted, and we wanted to make a record of that, mainly so that we could start building a history again for the purposes of sustainability, but also to provide us with a peace of mind that we could come back to the place that we were. In this next video, we're now going to think about what more code additions can we make in order to lean in more to this idea of sustainability. And we're going to look at testing. So remember, we went through this testing flow in the video. We talked about how there's a flow in which we write our test functions, or our functions to test even, which we've actually already done. We've got now our Pythagoras function. And so what we're going to do now is we're going to write a set of test functions to basically test the inputs to that function automatically. Because as you saw in the first video, when we were going through the testing of our program, we did a lot of things manually. We ran that program a lot of times. We entered manually into the console lots of input values when the program asked us for input in order to test that it was working. And hopefully you could see from that was actually quite a cumbersome process. So we can automate this, and we shall automate this. And we're going to do that, like I say, by writing some test functions, and then we're going to look at how we can run those test functions using a testing framework. So back to our coding environment, what's the first thing that we're going to do? Well, firstly, again, we're going to think about organization. We're going to make a new folder, and we're going to call it tests. And then we're going to double check from the command line that that folder exists. It does. And what we're going to do is inside this test folder, we're going to make a set of classes which are designed to perform different tests for us. At the moment, we've only got one function, so we're just going to make a Pythagoras test file, but we can imagine in the future we might have lots of classes which are designed to test all the different bits of these wonderful theorems that we come up with. So I'm going to make a new file. I'm going to adhere to naming conventions as I believe them to exist for Python. We're going to call it Pythagoras. I'm going to again struggle with the spelling of that. And we are going to make ourselves a class. We're going to call our class Pythagoras tests. And we're going to, well, first of all, I should probably have used the correct extension. And we're going to call this Pythagoras tests. And what we're going to do here is something that we've not seen before. We're actually going to do what we call inherit. And this is, again, is a fairly nuanced concept of programming, object-oriented programming specifically. But we are going to take all the code from one class and not make a copy of it like we saw in terms of making an object here. We're actually going to bring a load of code into this class that we actually haven't written, that someone else has. And what that will allow us to do is to access the methods of this other class, which is what we want. And that class is called unit test. So I'm going to import it first, like we've got you getting used to doing. And the specific unit test, the class that I'm going to import from the unit test module is the test case. And what we're basically saying here is we're telling Python this is a test case. When you inherit something, you become its type. So we're saying the type of Pythagoras tests is test case. And like I say, this gives us access to methods from the test case class. So we'll see that in a second. First of all, we talked a little bit about this concept of features, so we're going to look at that straight away. And the first inherited method is going to be something called setup. Again, we're using the keyword self to say that we're relating to the object. And what we're going to say is when we first start running our tests, there's something that I need, isn't there? I need, like we saw here, I need to create an object to the theorems class. That's key to running the tests because it's using that object that I'm going to call the different methods. So what I'm going to say is when I set up, I want to make an object of this class that I want to be available to throughout my other methods. So I'm going to say theorems equals theorems. And what I'm going to say is I'm actually going to say self.theorems equals theorems. And what this says is whenever I run these tests, whenever I create this test object, an object of this class to run these tests. We're going to go through this feature setup step, which is going to create an object of the theorems class for use within the rest of the program. Okay, so I'm now actually ready to write some tests that are going to test how this function works. And the first one is I'm going to actually just mirror the functionality or the inputs that I was adding to test the functionality of the Pythagoras method before manually. So you remember I kept entering 6 and 6 and seeing that the answer was 8.49. I did that manually. I did that a lot of times. So I now want to avoid doing that. So I'm going to say, I'm going to call it test basic here. I am going to, actually I'm going to, just for consistency, adhere to camel case there because that's the same as for the inheritance that I'm doing. And what I'm going to say now is I'm going to use a specific keyword. And that keyword is called assert. And what assert basically says is if the value after this is true, if it evaluates to the Boolean value true, then everything's fine. If it evaluates to false, then everything is not fine. And essentially that equates to the test passing or failing, respectively. So I'm going to call this theorems object. Remember, that's where the copy of the theorems code exists. And I am going to call now the Pythagoras method. And I'm going to pass it these numbers, remember, because now we know that the Pythagoras method equates to these numbers. And I'm going to say that I expect the value to be equal to 8.49. Okay. So here what I've done is I've created a testing class. I'm inheriting test case, so Python broadly is aware that this is a test case. I've created this setup step where I'm creating a feature. In this case, the feature is the theorems object. And then my first very basic test is going to be checking that the Pythagoras evaluates to 8.49 because I know this should be right if everything's running fine with the program. So I can now think about running this test to make sure everything is okay. Just going to confirm that I'm in the right directory. Now I'm going to call Python, and this time I'm going to tell it something. I'm telling it I want it to use the unit testing framework. And I'm going to tell it that the place where my tests are, I'm going to tell it where to look for my tests. I'm going to use the discover keyword, and then I'm going to write the test folder. So I'm running Python. This time I'm not compiling anything directly. I'm saying I want to use the unit testing module, use the unit testing framework, and I want it to discover any tests that exist within the test folder, which we know are this file test Pythagoras. I'm going to go ahead and run that. And here we go, our first error. Why is that not working? Well, of course, we have forgotten the key thing from theorems. We're going to import theorems, remember, like we did before. Try that one again. Here we go. Self is not defined. Little syntax error there. See, running tests already helping us out. And there we go. Everything is okay. Everything ran successfully. So you see, now I don't need to go into my, if I was doing this while I was building the program, I don't need to go in. I don't need to manually enter these numbers. I don't need to run through this user input. Yes, I could write normal testing functions, but again, I get this nice automated approach. When I use these testing frameworks, I don't need to go in and manually run every file. If I'd ignored the idea of inheritance and actually using a formal test framework, I could maybe have gone in and run all the files manually, but that's, again, quite a cumbersome process. So I've automated all these tests, and I can see, yes, equals 8.49. So let's now imagine if I go into my Pythagoras code, and let's imagine, again, I was doing this while I was developing, and I made an error. I did a plus instead. Let's run our test again. And it's failed. So, and it tells us exactly what the problem is. It's not spitting out the right number. So I could come back and I could say, actually, this should be plus, run my test again, and everything is okay. So again, speaking to sustainability, if I come along and I find someone else's code, maybe it's quite extensive and I can't really, maybe don't really want to go through and manually check everything that works. I could find how to test things. I could find maybe a nice folder called tests full of all these different tests. I come along, I run it, and it says everything, everything, did I do that right? Everything, sorry, that's my fault. I say everything passed, and I'm now quite confident that everything looks good and nice. Great. So let's just, for sake of example, write a few more tests. So I have on a sticky note next to me, it says that Pythagoras, 1 million, well, I've got some large numbers, let's just put it that way. So what am I going to do now is I'm going to show you another method that we inherit from the test case class. This is called assert true, and this is just another way of doing assert. It's nice to see how we've got these inbuilt functions that we can use. Again, we're going to call the theorems function on Pythagoras. This time we're going to call it with 1 million, and then we're going to test large. So again, this is this concept of trying to get these edge cases, checking how our code performs when we give it really, really large numbers. I might have an extra 0 there, we'll soon find out. And I believe, again, according to my sticky note, that this should equal this. Okay, like I say, we'll soon find out. So let's run our test runner again. 1 has failed, so maybe I've plugged in some wrong numbers here. Okay, so this, we're going to do 1 million by 100,000. There we go, everything's running fine. Good. Last case, another test case. I'm going to call this test negative. And we're going to say self.assert false. Again, call the theorems object. Again, call Pythagoras. And again, we're thinking a nice edge case might be how does our program respond to negative values? Let's run it, and we've got a failure. Okay, so this is not doing the right thing because, of course, Pythagoras should only respond to positive values. So this is actually now what we're starting to kind of edge in on what we call test-driven development. So we're using tests now to actually drive the development process, and I can see actually it'd be quite nice if I could say if side is less than A or side is less than, side A is less than 0 or side B is less than 0, I should return false. Because part of our test here is saying negative value should return false, and before it was returning a value instead. So again, test-driven development, this is showing us how these things should work. Run my test again. Oops, I have not being consistent there myself. There we have it. Everything runs, everything's okay. So that's a very rapid introduction to testing. Again, what's this got to do with sustainability? It's nice to be able to show in a succinct way that your program runs, that it can be trusted. And it also leads itself into things such as maintainability, like we saw in terms of test-driven development. It's allowed us to see errors and go ahead and fix them.